This is the 25th lecture in the Fiber Optic Association lecture series on fiber optics. In this lecture, we're going to be talking about fiber to the home. In the industry, we've basically gotten around to calling it FTTX because some people say FTTH for fiber to the home. For others, it's FTTP for fiber to the premises, FTTC for fiber to the curb, FTTN for fiber to the node. We've even seen FTTB for fiber to the business. So we lump all these together and we call them FTTX. It's for those who can't decide what really to call it. In telephone systems, about 10% of the cable is long distance, another 10% is local loop, but 80% of the cable is what we call the last mile, the connection to the subscriber. Since the long distance and local loop are virtually all fiber, and we have an aging subscriber loop made out of copper, fiber to the home is now just completing an all-fiber telephone system. Why are we looking at fiber to the home now? Well, one reason is we have an aging copper infrastructure. And many telcos are realizing that the alternatives to fiber to the home are inadequate for future bandwidth needs. DSL has already peaked because there aren't enough copper wires around that will support higher speed systems on DSL. It simply doesn't have the bandwidth. Wireless doesn't have the bandwidth. Everybody has a mobile phone, but they're not going to use it for the things they'll use fiber to the home for. And there's another option, which is broadband over power lines, and that doesn't have the bandwidth either. So we're going fiber to the home. Around the world, telephone companies, governments, cities, even private enterprise is realizing the value of fiber to the home. And as a result, millions of homes and businesses are being connected up over fiber each year. The future looks for strong growth. How do you implement fiber to the home? Well, you could just run a single fiber to every home and from every central office, but that's the most expensive way of doing it. You could run fiber from a central office out to an active node, a switch near the home, and a short drop cable to the customer. But that still means that there's an active link to every home. Some telcos that already have copper cable into the home use fiber to the curb. They run fiber to a local switch near the home and use the copper cables already available to connect the home using DSL, digital subscriber line. The problem is that the frequency or bandwidth of copper cable is inversely proportional to the length. The longer the length, the lower the frequency, with a limit of about 15,000 feet or 5 kilometers. So fiber to the curb, while it may be cheap, will not work in all circumstances and will not provide the high bandwidth of fiber. The secret to fiber to the home is an architecture called a passive optical network, or PON. A PON network uses an optical splitter. It splits the signal downstream from the central office to the subscriber as many as 32 times. So the cost of the electronics downstream is shared among all the connected homes. Upstream, it uses a single digital link using inexpensive components to keep the costs down. It's the passive optical network that provides the performance that is expected of broadband to the home at the lowest possible cost. PON systems don't necessarily have to use just one coupler. They can use cascaded couplers, so that if you don't have a high density of houses or subscribers, you can have, for example, a 4-to-1 splitter near the central office and another 4-to-1 or 8-to-1 splitter near the homes to save the amount of cabling that you need to support these homes. Like everything else in telecommunications, there are extensive standards for PON architectures. BPON, which was really the first type of PON used, at least in the United States, uses digital systems for voice and data, but analog for video, just like cable television. Although the systems can be upgraded to a total digital system by going to IPTV. GPON, or gigabit PON, works very similarly with total IPTV and digital voice and data, as does EPON, but EPON is different. Instead of using an ATM protocol, it uses Ethernet. Like everything else in telecom, PON systems have their jargon. The optical line terminal in the central office, or OLT, connects to a fiber distribution hub, FTTH, that houses the splitter and connects to the homes. A drop cable goes to an optical network terminal at the subscriber or the home, and that's then usually called an ONT. PON systems are wavelength division multiplexing running bidirectional on single fibers. The original BPON, which used AM video, sends video downstream at 1550 nanometers, sends digital data for voice and data at 1490 nanometers downstream, and the subscriber uses an inexpensive 1310 nanometer laser for upstream digital back to the central office. The cable TV industry has its own version of fiber to the home called RFOG, or RF over glass. It basically moves the cable modem from a pole outside your house or underneath the ground into the home. So it's basically a hybrid fiber coax system with the cable modem in your home. It works over exactly the same fiber architecture as other fiber to the home PON systems. And it allows independents who are building their own system to decide whether to choose the telco version of PONs or the cable TV version of PONs. But most people use the telco versions. A fiber distribution hub is designed specially for PON architectures because one fiber coming in goes into a splitter, usually in a tray, and then breaks out to as many as 32 different homes. So the management of the patch cords from the splitter to the home is very important. So these fiber distribution hubs don't become one big gigantic mess of cables. Fiber to the home also tends to use special splice closures, as you see in the picture to the left, where a cable comes in and continues on out from the top, and then multiple small drop cables are in separate ports. This is because you have one cable in, but you may have 32 cables out or more. On the right, you see something that's unique to fiber to the home, and that is pre-terminated cable assemblies, where you take a cable and instead of splicing to it, you simply have a weatherproof connector that you can connect a pre-terminated cable. We'll talk about those a little bit more in a minute. To save time and cost, many telcos use prefabricated cabling to drop to the home. The idea is that they install cables in a conventional fashion, but with weather-tight closures used on poles or underground near the home. For each home, they have a pre-terminated cable cut to the right length, which they merely plug in and pull to the home or lash typically to cables already running in the home for aerial. This method is typically used to save both time and cost for fiber to the home installation. At the home, we have an optical network terminal. It takes the optical signals coming from the central office through the splitter, converts them into video, voice, and data in the home over the conventional types of cables that you expect. Coax for video, unshielded twisted pair, what we typically call Cat5 for the computer, and plain old telephone service, copper pair, for the phone. Practically every fiber to the home network is unique. Every network is different. Engineering and installing a network of fiber to the home has to include the geographic layout where the system will be installed, what the current fiber infrastructure looks like, customer types, services being made available, and vendor requirements. There's practically no way to generalize on how to design a fiber to the home network. So each time you design one, you really have to consider everything involved before you put it together. More information on fiber to the home can be found on the FOA website and the FOA Online Reference Guide to Fiber Optics. We're the Fiber Optic Association, the professional society of fiber optics.